Hello and welcome to another one of my videos. Today I'm going to be trying to do the twin prime conjecture, or obviously not solving it, but trying to, you know how I've done the colorless conjecture before, right? So I will do like a little thing that does that and plots it into Matplotlib. So first, oh yeah, and I also only have this little function that I found on the internet, so I'm gonna start now on the import Matplotlib. Also, this is like the only video where I haven't planned anything, so like everything is going to be improv, and I'm gonna just be coding off the top of my head. On other videos, I usually spend like half an hour or so figuring out my own script, and then what I do is I put that script in another window, and then the OBS Studio in my second monitor, and then the script in the second monitor, so then I can just see it there. This one, not that much. I literally haven't planned anything. So as far as I know, the twin prime conjecture is that there's infinitely many twin primes, which are primes that are two apart, like two numbers apart, so 11 and 13. So I could do something like I forgot how the for loops work in Python, because usually it's like in JavaScript it's for let I 0, then something like this, but I forgot how to do them in Python. Let me check. Oh, that's easy. Oh yeah, so I was right. Oh yeah, okay, good. For I in range of, let's say, 300, then I don't know what it, let's see. If is prime I, then print I is a prime number, then it will check if I if I plus 2, oh yeah, so if is prime I plus 2, then I will print I and I plus 2 are twin primes. Then here else, then print I is not a prime number. So then we'll keep going. Let me test that now. What the heck? It's working, I think. Wait, that's a lot. Oh wait, I forgot. It has to be 301. Yes, so let's see if it got 11 and 13. Oh yeah, it works. Look, 11 and 13 are twin primes. It's true because 11 and 13 are twin primes. Look, 0 is not a prime number. 1 is not a prime number. 2 is a prime number. 3 and 5 are twin primes because 3 is a prime number. 5 is also a prime number. And then 4 is not a prime number. Yeah, and then look, 3 and 5 are both primes. So this means, but also 3 plus 2 is 5. So yeah, they're twin primes because they're two numbers apart. 5 and 7 are twin primes too. 11 and 13 are also. So how could we possibly plot it now? Okay, so first we have to actually import it correctly. Import it correctly. So matplotlib the pyplot as plt. This is like the usual shortened way. You can put this as whatever you want, but to make the code shorter, we can just do plt. Then we can go like we can create an array or a list, whatever you call it. So we can make a list right before the loop. I'm gonna make it. How do you make a list in Python again? Okay, whatever. I think it's just like this: x equals empty list, then y equals empty list. Then if a twin prime is found, then x dot append I, and then y dot append 1. This is only to show the density of the twin primes, to see how much gap there is between twin primes. So then at the end over here we can go like plt dot, oh what the heck, I didn't know suggestions like this. So a lot of stuff here. I think it was just like plot, yeah, here plt.plot, and then we just did x, y, something like that. And then just try it for now like this, plt.show, and I'll try this for now. Let's see if it actually works. Let's see. It's not even doing anything. Oh, okay, there we go. So it doesn't seem to have shown up as expected here. It doesn't really show anything. It's just a straight line. And I think I know why. It's because I forgot to append stuff for this. So for when it's not a prime number, or twin prime at all, we still have to append it. But at this time we have to append a 0 instead of 1. So I guess that should work now. Yep, it seems to be working. Well, not the plot part, but let's see. Oh yeah, it is working. See, if we start out here, it gets progressively, like the gaps start to get kind of wider, I think. See, look, it starts with like really short, small gaps. Wait, how do you zoom in? I forgot how to use it. I want to zoom in. Let's see here. And then, as the numbers grow, the gaps get bigger. But look, it's not like consecutively bigger, I think. Because look, if there's small gap, big gap, the same thing. But look, a big gap, small gap, big gap, small gap, big gap, small gap, and it just goes on like this. So maybe we could do a bigger range to see more cool stuff. So instead of just doing 300, I'm going to do 1001. So it's actually perfectly 1000. And then it's going, and we're gonna have to wait a bit because, it's Python is not that fast. It's not the fastest programming language. It is pretty fast. Like a human would not be able to do this calculations so fast. But Python, compared to other languages, is not the fastest either. Oh, and see here, the gaps are getting bigger, and the small gaps are getting even smaller, or at least from perspective. It looks pretty wacky here. It looks like a barcode. It looks really wacky. Oh yeah, I forgot to add labels. So let's go back to the code, and then we could add stuff like labels. plt.label. Wait, like title, I think it is. Title. Twin prime conjecture gaps. Forgot the end in parentheses. Then we could do, I think this is how you do it. Like this maybe? Or is it like this? And plt.x label would be iteration, and then plt.y label would be is it twin prime. Wait a second, I think there's still like a little error in this, because it's pending if it is a twin prime, but not all primes have a twin prime. So that means there's some missing iterations in here that we could possibly add by just doing a quick else block over here, and then just doing this thing again. So that way it still appends to the list, even if it's not a twin prime, only a prime number, and it will be 0, obviously. I think that's how it works. I might be a little wrong here, but I'm pretty sure this. Let's see here. It'll take a while to get to 1000. Then 1000. What? Oh yeah, I knew I was wrong in that. Just like this. Then the marker. Let's see, for fun, why don't we do a star? This is like the one thing I remember because it's funny. We can remove this thing now. It's pretty useless. And then the label would be, I don't know, I don't need a label for this. And we can do plt.legend and then run it. It's as simple as that. Now we're gonna have to wait all the way, so it gets all the way up to 1000 again. 500, 600, 700, 800, 900, and 1000. Okay, but at least it worked, huh? Yep, just little stars at the top. Oh my god, what is up with the bottom now? Yeah, is it twin prime iteration? It works. Yep, it works. Uh-oh. What is going on here? Okay, at least it works, but now we just want to have a little bit of fun. What are the different line styles? Are there stuff like maybe does this exist? Wait, I already tried that. I want to see, that's just a dashed line, right? Oh wow, that looks horrible. It genuinely looks, I mean, it looks like a rope. I think I'm seeing things that they look like they're supposed to be moving. They're so compact together, like they're so close together. They look really weird. These ones don't even look like. Look, if you just look at them from far, these ones over here don't even look like actual dashed lines. They look like little zigzags. This one looks like a little shock thing. This is just a zigzag or a chain. Well, that's pretty cool, I guess. This is the end of this video. Have fun and don't forget to keep coding.